Welcome to MathLink Academy, where we connect the dots. I am Mr. C, and I will be covering in this particular unit, we're going to talk about powers, negative signs, or negative exponents, and then also square roots. And so let's look into how that looks and let's get started. So let's look at powers of sign numbers, powers, exponents. Determine values with positive exponents. That's what we're looking at. We want to apply the procedure for multiplying signs, multiply to raising a sign number to a power. A positive number raised to any power is positive. A negative number raised to an even power is positive, and a negative number raised to an odd number power is negative. Again, the key I want to show you for the last two is important. If you have a negative number and you're raising it to an even power, your answer is positive. If you have a negative number, you're raising it to an odd power, your answer is negative. And we can look at some examples for that. So let's look at this. It says evaluate 2 to the 4th. So let's evaluate this, 2 to the 4th. Now, what does that 2 to the 4th mean? It means I'm taking the base 2, that's my base, and my exponent or my power is 4. And I'm taking that base 4 times in multiplication. That's the key, 4 times with multiplication. So what we're saying here is that 2 to the 4th can be expressed as the base 2 times 2 times 2 times 2, 4 times. The power only tells you how many times that you're multiplying the base. Can you express that enough? It's multiplying the base. And in this case, we just multiply 2 times 2 is 4, times 2 is 8, times 2 is 16. And this is my final answer, 16. Let's look if we had to evaluate a -3 square. How would you write that long ways and then find out what the answer is? What that's saying is I'm taking -3, the base, and I'm multiplying it twice. That's basically what it's saying. Notice we got 2 negative, we're multiplying 2 negative, so we know our final answer would be positive. This is saying here's a even base, so your final answer will be positive. So this would be a +9. Let's do this one. Let's do a -3 again, but raise it to the 3rd power. And so that 3 is an odd number, and we have a negative base. That means your final answer will be negative. So let's prove that. So this is saying a -3 times a -3 times a -3. So -3 times a -3 is a +9 times another -3. The last one will give me a negative number, a -27. So my final answer will be a -27. So that is our rule. If you understand, if the power is positive, we end up with those positive values. If it's negative, and we're talking about for negative base, just the negative base, if it's odd, then we end up with a negative value. Let's look at this example. Will our answer be positive and negative? First ask yourself that, and then what will be the answer? So for this one, we're looking at a -4 raised to the 3rd power. So another way of looking at it is -4 times a -4. Notice how I'm writing it, times a -4. I'm putting in parentheses so we know those are negative. Now my final answer, when we multiply these two together, this gives me a +16 times a positive or -4. And therefore that would give me a -64 if I did that correct. So my final answer for this one will be a negative 64. Now let's talk about negative exponents, which is our next subject in this particular unit. Two numbers whose product is 1 are multiplicity inverse or reciprocals of each other. So I'm going to go to our whiteboard and show you what we mean by negative exponents. Before, we've just only been working with positive exponents, 2, 3, 4, whatever. But now, what does negative exponents mean with the number? So on our whiteboard, I want to write down a number 2, and that's supposed to be a 2, and raise it to a negative 1. Now, the power is negative, and I want you to make sure you put this in your mind or write this in your notes, that when the power is negative, it does not change the sign of the number. It's just flip the number. That's all it does. The number will have the same sign as before. All the negative will flip it. And so our goal is to make that negative 1 a positive 1, and it doesn't change. So this is basically how you look at it. A negative 1, so this is 2. Let's write that a little better. 2, and it's looking worse now. To the negative 1. We have this, guys. So this 2 to the negative 1 is one way to look at it, is to you want to get rid of the negativeness of your power. How you do that, you take the reciprocal of the base. So what's the reciprocal of 2? The reciprocal of 2 is 1 over 2, or 1/2 to the positive 1. You keep that 1, and that's your answer. And so my answer here would be 1/2. That's my answer. So let me show you again. Keep this up here. Let's look at it again. Let's do 2 to the negative 2. What would be the answer to that? Again, what you want to do is get rid of that negativity of the power. How do you do that? You take the reciprocal of the base and leave everything else the same. So the reciprocal of 2 is 1/2, and that's how we got rid of the negative, and then we'll just keep the square there, the 2. And in this case, this could be written as, we distribute, 1 squared is 1, and this is a 2, guys. So our answer here will be 1/4. Let's do another one. Let's say we have 3. 3 to the negative 3. Now our goal is to get rid of the negativity of the power. That's your goal. Always think of that. And then write the final answer. Now to get rid of the negativity, you take the reciprocal of the base. In this case, it'd be 1/3. And then the negative sign is gone. And then we'll just keep the 3 like we did previously. So this will be 1/3 to the 3, 3 to the 3, because we distribute. What I just basically did is distribute here. And this gives me 1 times 1 times 1, and 3 times 3 times 3. I believe it's 27, and it gives us this as a final answer. Let's do another one. Let's look at another page. Let's do a few problems here. Let's say I have the number 1/2, and I'm doing it to the negative 2 power. So hopefully it comes on the screen. And what we're going to do, we're going to convert that and write the answer. All you want to do first is get rid of that negative sign in the power. It doesn't change the negativity of the problem. It just takes the reciprocal of the base. The base is 1/2. What is the reciprocal of 1/2? It's 2. It's 2 over 1. It's another way of looking at it. And then what it does, it get rid of the negative sign, but we still keep that 2 or that square. And so we actually end up with 2 raised to the 2nd power, which equals to 4 in our case. Let's do another one. Let's look at another one. Let's say 3/2. and I'm saying raising to the -2 power. Again, we want to get rid of that negativity of the power. That's the key. Always think of that. You want to convert it to a positive value. So how do you do that? You take the reciprocal of the base. In this case, it'd be 2/3 square. So that's the reciprocal of the base. And we got rid of it. Once you take that reciprocal, you get rid of the negative, and that square, and this would be 4, because we can distribute this as a power up here and a power there. 4/9. 2 square. Let's do one more. Like you said, Mr. C, let's look at some negative values. Right, let's look at a negative one. Let's say a -3 halves to the -3. Again, we're only going to focus right now on the negativity of the power to make it positive. Now, our base is negative, but let's look and see how we can do that. So look at this, guys. So I'm going to show you this. This is a -2/3. I took the reciprocal of the base, and that helps me get rid of that negativity. Now, what I can do next is this is raised 3 times. So another way of looking at this, we're looking at -2/3 times a -2/3 times a -2/3. That's basically what it's saying. So 2 times 2 times 2, and notice we have an odd number of negatives, so my final answer will be negative. And this gives me 8/27, and it's -8/27 because of our negativity. Do one more. Even though I said that's one, let's do one more, and then we'll jump into something a little different. Let's just watch this here. Let's say you had a -1/2 raised to a -2. What is that saying? The first thing you want to do is get rid of that negativity with the power. How do you do that? You take the reciprocal of the base, which gives me, you don't change, you just keep the negative, -2/1. And that's a +2. So now my exponent, my power is positive. Now, let me rewrite this. You actually can write this again. A -2/1 is the same thing as a -2 square. And in this case, watch this, I'm going to bring it down here with my arrow. This is -2 times a -2, which it gives me what? A +4. Again, just look over some of the examples that we did to get a clearer understanding of how we're doing this. Now, the last thing we're going to cover are roots of sign numbers. A root of a number is a quantity that is taken 2 or more times as an equal factor of the number. And that's key, an equal factor of the number. Roots are expressed with radical signs. Is a radical sign, radicand sign. An index is the number of times a root is to be taken as an equal factor. The square root of a negative number has no solution in the real system. So that's key right there. The square root of a negative number, square root of a negative number has no solution in the real number solution. So let's look at some examples of how to do roots. So in this case, as in our whiteboard, let's start with the square root. The square root is written like this, square root. Back in the day, they used to put a 2 here. We don't do that now, but for right now, I'm just going to put a 2 there. And it means what 2 of the same number would give you what's inside the radicand. And so let's look at this. Let's look at 4. What 2 numbers, they have to be the same 2 numbers you multiply, will give you 4. And why are we looking at 2? Because we have our 2 up here. So another way of looking at it is 2 times 2 equals 4. That's inside. And so my answer here, the square root of 4 is 2. What you're basically doing is taking out every 2 numbers that are the same. You take it out the radical. Take it out the radical. For example, let's look here. This would be the square root. And I'm not going to put the 2 there because anytime you have the square root, we already know that that means square root. If we have another number, index, I'll write that. But if I don't write the index, it's always the square. So what is the square root of 9? In our case, what 2 of the same numbers give you 9? If it's possible, if you can figure that out. So it'll be 3 times 3. So since we're looking at 2, you take like 2 at a time out the radical. And this is equal to 3. So the square root of 9 is 3. So what's the square root? Let's keep going to 16. Anybody tell me what you think that would be? What 2 numbers that are the same will give us 16? Must be the same. In this case, it would be 4. 4 times 4 equals 16. Let's do another one. Let's do the square root of a negative 4. So we want to figure out what 2 numbers that are the same will give me a negative 4. Now we know 2 times 2 is 4. And we also know 2 times a negative 2 is a negative 4. But the problem is, and hopefully you'll see this on the screen in a second, 2 and negative 2 are not the same number. And this is the only way I can get a 4 is if one of the numbers must be positive, one of the numbers must be negative. Since I don't have the same number, not the same, these are different, then I have no solution. Not in the real. So there's no solution, not in the real numbers. So you cannot take the square root of a negative number. So there's no solution. Let's look at some more. Let's look at some more. Now, that is square root, but now I'm going to put a 3 here. It changes. It's not a square root anymore. It's a cube root. And let's use a different number. Let's use the number 8. So I'm going to put the number 8 inside the cube root. And now I'm asking what 3 numbers, now not 2 numbers, but 3, because the index is saying the 3 numbers got to be the same. That gives me 8. So we can say 2 times 2 times 2. Does that give me 8? 2 times 2 is 4 times 2. Yes. And those numbers are all the same, exactly the same. So that means the answer to this will be 2. Take 3 out at a time, out of the radical, and it gives us the answer 2. So the cube root of 8 is 2. Now, let's look at some other ones. Let's look at the cube root. Let's give another number of 27. Is there a number that you multiply the same number 3 times that gives me 27? Let's see. So we're looking at the radicand is 3. And so that's what we want to look at, guys. So in this case, we're going to have the radicand. Again, this is 3. Let's put down 3 here. It will be 3 times 3 times 3. And since these 3 numbers are the same and they give me 27, which is in here, then the answer to this problem will be 3. Let's do another one. Let's say the cube root of a negative 27. Can we do that? Is that possible? Are there 3 of the same numbers that would give me a negative 27? Let's see. So cube root, we have a negative 3 times a negative 3 times a negative 3. Now we know from the previous example, we can use 3, 3, and 3. But let's try all 3 of them being negative, because you can't have one being negative, one being positive. Let's try all 3 being negative. Let's see if that works. So negative 3 times a negative 3 is a positive 9, times a negative 3 is a negative 27. So this does equal a negative 27, and all 3 of these numbers are the same. So in this case, the cube root of a negative 27 is a negative 3. So let me just tell you something very quickly, is that if you had, I'm going to go to a clear screen so you can see this. If your radicand, and once you understand this, if this is a even number like 2, 4, 6, 8, you cannot have a negative number inside. You cannot, and if you had a negative number, it'll be no solution in the real number line. If your radicand has an odd number like 3, like we did before, or 5 or 7, and you had a negative number, you can have a solution. Matter of fact, with the odd, you can have negative and positive. With the even, you only can have even numbers or positive numbers, inside the radical. So for this last part, again, let's recap the roots of signed numbers. The expression, or that radicand or radical sign that we have, the index is 364 is in the radicand. It says use the following chart to determine the signs of a root based on the index and radicand. Now the index, if the index is even and your radicand is positive, then the root will be positive. If the index is even and the radicand is negative, the solution is no solution. If the index is odd, it doesn't matter if it's positive or negative for the radicand, your answer would be either positive or negative. You can get a solution. So it's that even one you got to look at when it's a negative number or a negative radicand, and then you have no solution for the root. So hopefully this helped out to have a better understanding of how to find the powers, negative exponents, and also how to find roots of numbers. Again, review this video again if you want to look again how to look at doing the particular units or the particular subject matter that we're talking about with powers and radicands and exponents, and also look at some of our supplementary material on our MathLink Academy website. Again, thank you for watching our MathLink video.